Welcome. In this video, we're going to be looking at how to name ionic compounds with transition metals. In the previous video, we looked at a brief introduction to naming ionic compounds, and those are very simple examples. But in this video, we're going to be having a special focus on transition metals. If you want to review some of the ionic compound nomenclature, feel free to check out the previous video, which I will link to the bio. All right, let's get into it. The first thing I want to look at in this topic is to identify what a transition metal actually is. And if you zoom into the periodic table over here, a transition metal, it refers to a group of metals from the third group over here all the way to the 12th group over here. All right, these metals are all referred to as transition metals. As said in their name, they are a type of metal. And what makes these metals unique, in particular to ionic nomenclature, is because they have the property of having multiple ions due to unfilled d subshells. So we won't be getting into those details for this video, but for now, we need to realize that all the elements, all the metals here, are capable of having multiple ions. So what does that mean? Let's go over here. Iron can have ions of iron 2+ or iron 3+, and it is a transition metal. This is different from the other metals, like the ones on the left-hand side over here. For example, potassium only has a K+1 charge. It cannot have any other ion, but transition metals, due to their unique electron configuration and their d subshell, they are allowed to have multiple ion charges. And this is very important when we're naming things, because, for example, say I were to name a compound iron oxide, right? From this name alone, it would be impossible to tell which iron ion is involved in the iron oxide compound. Is it the iron 2+? Is it the iron 3+? There is a great deal of ambiguity due to the multiple ions. So what happens when we name ionic charges, what happens when we name transition metals, is that we use Roman numerals to indicate the charge. So for example, if I were to name the iron oxide with the Fe2+, it would look like this. To indicate the 2+, I would include 2 in Roman numerals surrounded by brackets, and then oxide, iron 2 oxide, and then say I were to do it for the iron 3+, iron 3 oxide, iron 3 oxide. All right, so these Roman numerals distinguish between the different ionic charges that iron can have. All right, and if you don't know your Roman numerals, it's also perfectly fine. I'll just write them out over here. These are the different Roman numerals from 1 to 5. These is pretty much all you should know. And 1, 2, 3, 4, 5. All right, so we'll be using these whenever we name transition metals with ionic compounds. So using this, we're going to get into some example questions, and we can get started on that. So if you feel comfortable, you can pause the video, get started with a few of these questions, and then you can check back. If not, I'll work through these examples right now. All right, so we need to name this compound, and you see that there's going to be an iron, and there's going to be 3 chlorines. All right, so what we remember from earlier is that there's an ambiguity as to what charge the iron's going to have. So we're not going to focus on that. Let's start off with what we know. There's 3 chlorines, right? If you go to our periodic table, we know that chlorine is in this group over here, which means it has a -1 ion charge, right? That's not in question. We know that for sure. So since there's 3 chlorines, this section over here is going to have a 3- overall charge. It's going to have a -3 charge. What you need to remember is that the overall compound is going to be neutral. So that means the only other part of the compound, the iron, needs to neutralize this -3 charge. And how does it do that? Well, there's going to be only 1 iron. So the only way you can do that is if the iron had a 3+ charge. Now the overall compound is neutral, and that is the ion that is used in this compound. So if I were to write it out, it would literally be iron, right? And then since we determined it's a 3+, we're going to write 3 in parentheses. Note that when you're typing this, some teachers are very picky when it comes to the space over here. Make sure the bracket is right next to the iron. So that's very important in virtual school and that kind of thing. So iron 3 and then chlorine, but the IDE ending for ionic compounds. So it's going to be iron 3 chloride. All right, let's do the next question over here. Here we have 3 coppers and 2 phosphates. Phosphate is a polyatomic ion, which has a net charge of 3 minus. So if you want, you can write that in over here. And we do the same process here. Don't let the polyatomic ions kind of mess you up. What we do is we take the part that we do know. So copper can have either a 1 plus charge or a 2 plus charge. But the polyatomic ion is going to have a 3 minus charge. And since there's 2 polyatomic ions, this section of the compound is going to have a net charge of a -6, or I guess -6 actually. Or, yeah, so a -6. All right. So same concept. This part of the compound is going to have to neutralize the -6. So what charge would the copper have to neutralize the -6? And keep in mind that there's 3 coppers. So from this, it's pretty obvious that it has to have the 2 plus charge, because if there were 3 2 plus ions, that means it'd be a 6 plus net charge, which would neutralize the charge and produce a neutral compound. All right, so that means the copper is going to be the 2 plus copper. And if you would write this out, it would be copper, copper, and you're going to have the 2. Make sure the parentheses is right next to it. And then you're going to have phosphate, right? And note that phosphate is a polyatomic ion, so there's going to be no IDE ending. All right, let's do the last 2 over here. These ones are quite similar, and this example really illustrates the difference in ionic charges. So here you have, if you're unfamiliar with this compound, this is mercury, and you have mercury, and then you have oxygen here. Now mercury can either have a 1 plus or a 2 plus charge. So what you want to do here is you want to determine which one it is. So for this example, you know that oxygen, if you look at the periodic table, it's in this period over here. So this group over here. So it's going to have a 2 minus charge, right? So oxygen is going to have a 2 minus charge. So that means this part of the compound is going to have to neutralize it, the 2 minus, right? So there's only 1 mercury because there's no subscript. That means it has to be a 2 plus to produce an overall neutral compound. So if we're going to name it, we're going to have mercury. This is the name of the element. You're going to have the 2 plus charge, as we mentioned earlier. And then you're going to have oxygen, but the IDE ending. So it's going to be oxide, right? That's how you name that. And the final example here, very similar to the previous one, is very similar. But for this example, you actually have 2 mercury. So we know the oxygen is going to have a 2 minus charge. But now, remember how the mercury could have either the 1 plus or the 2 plus charge? Since there's 2 mercuries, this means that we're going to have the 1 plus mercury involved in this compound. Because if you had the 2 plus, you'd have a 4 plus charge and a 2 minus charge, which gives you an overall 2 plus charge. The compound's supposed to be neutral. So if we have 2 1 pluses, that gives you a 2 plus in total, which balances it out and makes the overall compound neutral. So if you were to name this compound, it would be mercury 1 oxide. All right. So in this video, we looked at ionic nomenclature, naming ionic compounds with transition metals. We looked at what transition metals are, where you can find them, and strategies you can use to name these kind of compounds. Hopefully you enjoyed the video. If you did, please like the video, consider subscribing to the channel, and I hope to see you guys in the future videos.